Okay, wonderful. Let me go ahead and share my other screen and then we can begin. All right, this one. Okay, so we're going to look at different function operations. And basically, we learned what functions are, and we learned function notation, remember, in the form of f(x). We learned that that's function notation on Wednesday. And so now we're going to look at function operations. So our actual operations take part in those functions. And so the first one we're going to look at, give me 1 second, actually. Here we're going to look at this function operation, and this one is asking us to add function f of x to g of x and then simplify. And so there's a certain rule for adding functions together, and the blue box represents that rule. And so what we're going to do here is we're going to add, so remember we use red to represent add. And so I'm going to show you how exactly to do that. So it says all you have to do is put the fx function on one side, the addition sign, and then the gx function on the other side. So more specifically, that will look like x2 plus x minus 6. And as you can see, I'm getting these functions from right here, f of x and g of x. And so now that I have my function in the way that it needs to be, I can go ahead and simplify. And so the way that I'm going to simplify is here we don't have any like terms, and so all we have to do is drop those down. And because we don't have any like terms, we don't have to simplify any further. And so that is how we would conclude this answer. Okay, does anyone have any questions how I combined or added f and x together? Any questions?
Yes, Miss. How you do like find the x2 in the left one?
x2 is right here. So f of x is equal to x2. So when I have to put fx right here on this side, I'll just put x2 because it's telling me f of x is equal to x2. So I'm just going to substitute those in. Does that make sense? Here, I'll draw some arrows. Oops, that's not what I meant to do. Okay, so here, let me write this down. fx plus gx, right? That's what it's telling me to do right here. Oops. Let me use green. On this part. And so that's what I've moved over here. And so now I'm just going to substitute my fx. fx is x2, so I substitute that right there. And then I substitute my gx. gx is x minus 6, and so I substitute that right there. And then I don't have to simplify because I don't have any like terms, and so that's where I end up on the last part. Did that help you?
Yes.
Yes? Okay, wonderful. Okay, so now we're going to go ahead and actually substitute a variable into that function. And so again, it's telling us here to do f plus g, but now instead of x, we have minus 1. And so what we're going to do is we're going to substitute minus 1 into our x's. But first, we want to create the equation that we're going to use. And so we're going to do f x plus g x. Okay, and now I'm going to substitute what is fx. fx is x2 plus, and then gx is x minus 6. And then remember we saw that we couldn't simplify, so we don't have to simplify. But what we do have to do now is substitute that minus 1. And so I'll do this. And what do I get when I do this? Well, on this side, it's telling me to multiply -1 times -1, which is equal to 1. And then on this side, I am doing -1 minus 6, -1 minus 6. And so I get -7. And so when I have 1 plus -7, I get -6. So that would be my answer at the end. Okay. Any questions about this?
No.
Okay, so basically what you do here is you just do what we did over here. You create your equation. We get the same equation here. But now what we're going to do is substitute the -1 in, and that's how we get to -6. Okay. So now we're going to look at functions and use the table of values. So basically what we have here is what we're going to do is we're going to find out what the function would be for every x value. So here we have the function x2, right, that we saw on the other side, and this one was x minus 6. And so to create a table of values, what you're going to do is basically substitute the x in. And so this would be -2, 2. This would be -1, 2, 0, 2, 1, 2, and 2. And so basically what you're doing is you're taking these x values and substituting it in for x here. And then once you do that, you can go ahead and solve. So -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. Then you'll do the same thing for the other side. So I'm going to substitute my values of x. So -2 minus 6, -1 minus 6, 0 minus 6, 1 minus 6, and 2 minus 6. Oh, 1 second, guys. Okay. And so you'll solve -2 minus 6 is -8, -1 minus 6 is -7, 0 minus 6 is -6, 1 minus 6 is -5. 2 minus 6 is -4. And so basically what you're doing again here. No. So basically what we're doing here is you're substituting each of these x's into the x here and then solving for those. And so now what you're going to see is that when you create these table of values, what you can do is add your resulting numbers together to find out what f of x plus g of x is. And so let's look at the example that we had earlier, which was -1. So if I add my resulting values together, what I see there is that I have 1 and -7. And so if I add those together, 1 plus -7, I will get -6, which is what I got there before. So basically, this is just another way to go about solving that type of equation. You could input each of the x's individually and then add them like we see here, but it's whatever your preference is. Even though this may be a little bit of a lengthier process, it's doing the same thing. Oops, sorry. Any questions?
No.
Okay. Now we're going to look at what happens when we subtract. So over here, we added two functions together. Now we're going to look at what happens when we subtract two functions together. So here is our rule for subtracting two functions together. Basically, we substitute fx and gx and then subtract. So fx minus gx. Fx is x squared minus x minus 6 Okay. Let me go ahead and put them in parentheses so we can see this easier. And now I'm going to go ahead and simplify. And I'll get x squared minus x plus 6. And so that is my simplified version of subtracting those two functions together. And if you're wondering how I got plus 6, well, I do have a negative here that I can distribute into both of these. And so that would make this a negative x, and then a negative times a negative would give me a positive, and so that becomes positive 6. Okay. Any questions about how I got x squared minus x plus 6? Okay. So again, this is for subtracting two functions together. All right. So now we're going to move a little bit further, and what we're going to do here is we are going to apply the function rules for adding, and then we are going to solve. So this one says the function hx is the sum of fx and gx. So that's what we have here. The function hx is equal to fx plus gx. So then it's saying find what the function h1 is. So basically what we're going to do is we're going to add fx and gx together. And again, we saw fx plus gx. Fx is equal to x squared plus gx, x minus 6. Okay. We saw that we don't simplify that any further, so that's where we end up, which means that hx is equal to x squared plus x minus 6. Okay, so now we have a function for hx. So now the next step we want to do is we want to go ahead and insert 1, substitute 1, because instead of x, we have 1 into our x values. So like this. Okay, and now we can go ahead and solve. And what does this tell us? This tells us we're doing 1 times 1, 1 plus 1 minus 6, negative 5, 1 plus negative 5 equals negative 4. And so our answer is negative 4. Anyone have any questions on how I did this? No? So basically what you're doing here is you are creating a function, and that function is hx, and it's telling us the way to create that function hx is to actually go ahead and add fx and gx together. So that's what we did, and so hx would be equal to whatever fx plus gx is, and then we're going to substitute 1 inside and then solve, and so that gives us minus 4. Okay, perfect. So now we've done adding functions together and subtracting function together, and we looked at those function rules, the ones in blue. And so now we're going to look at what happens when we multiply and divide functions together, and then we'll be done for today. So multiplying functions. So there is a specific rule for multiplying functions like there is for adding functions and subtracting functions. And so this is what that rule looks like. When it tells us that f times g, the function is f times g, we have to multiply the equation for fx times the equation for gx. So in this case, that would look like x squared times x minus 6. And then we know when we have something like this, what we have to do is distribute across. So we'll distribute our x squared across like this. And this gives us x cubed minus 6x squared. And if you're wondering how I got x cubed, let me go ahead and show you. So we have an x here by itself. And what we can think of is it has an imaginary 1 on top of it because it's just x by itself. It's not x squared or x cubed, it's just x. So it has that imaginary 1 exponent on the top. So now whenever you have to multiply x squared times x1, well, we're going to learn that there's a certain exponent rule that tells us that we need to take these two exponents together and add them. So that becomes x2 plus 1, which is x cubed. Okay? And then for the other half, I'm just adding the x squared onto the negative 6. Okay? So this is where I end up. This is my simplified version of fx times gx. Okay. Does anyone have any questions on how I got here?
Miss, yes, how do you do x, Miss, again?
How do you get x3 again?
Yes.
Okay, so we're going to look at exponent rules a little bit more later on, but basically what you have to do, and I'll go ahead and just do it again, is here we have x squared, and here we have a regular x by itself. Well, we can think about x by itself as being x to the power of 1. Whenever you see an x by itself, you can always think of it as having x to the power of 1. So basically, whenever we distribute, here, let me erase this. Okay. Whenever we distribute x squared and multiply it by x to the power of 1, what that actually looks like is x squared times x to the power of 1. And what we're going to learn is that when you multiply the same variable with different exponents on the top, you can add them. So x2 plus 1, and then 2 plus 1 is 3, so x3. And so that's how we get x3. That would happen if I even have to multiply x squared times x squared. What we're going to learn is that the rule is to always add these exponents together. So that'd be x squared, x2 times 2, which gives us x4. And so that's just the rule that happens whenever we're multiplying two variables with different exponents together. Okay, does that make sense?
Yes, I know.
Okay, perfect. Okay, so now we're going to get into division. And division's a little bit of a different process at the end, but it's fairly simple. Okay, so now we're going to look at our rule for dividing. And our rule for dividing basically just says we take our fx and divide it by gx. Okay, so fx divided by gx. And what I'm going to do now is I'm going to simplify, put in my different equations, substitute. So x squared minus x minus 6. Okay, so this is where I end up. Now, whenever you're dividing, what you have to do is you also have to include this part of that operation. And the way to solve for that part of that operation is you have to take the denominator, the bottom half, and you need to determine when it will equal to 2. So x minus 6 equal to 0. Okay, so when will x minus 6 equal to 0? Well, when you add 6 to both sides, you'll see that x is equal to 6. So when x is equal to 6, that bottom half will equal to 0 because we'll substitute 6 for x minus 6, which is equal to 0, which will give us minus 0. And so basically what I'm saying is you need to put your resulting equation after you do the division of fx and gx, and it needs to look exactly like this. And so how it's going to look exactly like that is you're first going to do fx and gx. And then in order to find out when gx is equal to 0, the bottom half, you have to find when the bottom half is equal to 0, and that's when x is 6. And so this would be substituted by 6. So therefore, your resulting equation will look like this. Okay, does that make sense? Does anyone have any questions?
No.
Okay, let me do a different example just to make sure we understand. Okay, let's say that gx was equal to x minus 3. It wasn't equal to x minus 6. Let's say it was equal to x minus 3. So if I'm going to divide those two together, then what I'm going to do is I'm going to do x squared minus x minus 3. Okay? But according to this operation, I have to include this part of the resulting operation. And so that means I would have to find out always when the denominator is equal to 0. Well, in this instance, the denominator is equal to 0. Let us see when that happens. When x is equal to 3. So because I know that, I can go ahead and put that my resulting operation is x squared, x minus 3, and gx is not equal to 3. So the second part of that operation, this always indicates when that denominator is equal to 0, and I always have to include that as my resulting operation. Okay, questions? So I'll put this here. You also need to find the value of x where the denominator is equal to 0. Okay? Wonderful. So now here's another example that we can go through of multiplying each of our functions together. And so what did we see when we multiply each of our functions together? Well, we quite literally multiply them together. And so that will look like x minus 6 times 6x cubed minus x squared. And now what I have to do is use my FOIL to simplify. So first I'll do dx. Okay. That gives me 6x4 minus x3. And again, how do I know that? Well, think of an imaginary exponent of 1 there. And so x1, let me write this like this. x1 times 6x3. What do we learn about exponents? If you have to go about multiplying them, then you basically just add them. So that would give us 6x1 plus 3 or 6x4. So that's how we get 4 here. Okay, same thing goes for every time we are adding, multiplying exponents together. And then I'm going to simplify the next one. So that would give me okay, and now what I want to do is simplify. Do I have any like terms? I do in fact have like terms. This term and this term both have x cubed, so those are like terms. So basically I would have to, in this instance, put them together. So basically, we're just using the FOIL method to go about combining those different equations together, and then this is where we end off. Okay. Any questions about this one?
Miss, just add them the 36 and x.
The 36x cubed and the other x cubed, add those together?
Yes.
Yes, you do. Because this would have like an imaginary 1 in front of it, right here. So you would add those together. Yes? Okay.
Yes.
Okay. So now we're going to look at one more example of when we have to divide two functions together. Remember, our rule tells us that we just substitute those in. So like this. Can we simplify any further? Well, we can, in fact, simplify. Let me show you what that looks like. I should have written that a lot smaller. It's okay. Can we simplify this any further? Yes, we can, and let me show you where. We have an x squared right here, and we have an x cubed right here. Well, that means that we can go ahead and simplify an x squared out of it. So that would look like and then you would keep the x squared on the bottom. So basically what I did here is I simplified an x squared out of it. And by doing that, I still have a 6x here. And then just imagine there's an imaginary 1 on top of that. And then because I took out x squared, I still keep the imaginary 1 that was right here in the front. So therefore, I simplified that. But remember, that's not all I have to do. Whenever my operation tells me that I have to find whenever the bottom part, the denominator is equal to 0. And in this instance, the denominator is equal to 0 when x is equal to 0, because 0 times 0 is 0. And so I will get oops, sorry. That's not what I meant to do. The bottom half was the fx. So fx. And there I would find my resulting after doing the division of those two functions on top of each other. Anyone have any questions?
Miss, I'm still confused, Miss.
You're confused with division or all of them?
All of them like you did right now?
So the adding, subtracting, multiplying, and dividing?
No, Miss, I mean you did dividing, Miss.
The dividing, okay. So dividing, okay, here, let me go like this. Okay, so the dividing rule tells me that if I'm dividing two functions together, say f and g, then this is the rule I have to follow. I have to put the f equation on the top, the g equation on the bottom, and then I have to find the instance when my bottom equation is equal to 0. Is equal to 0. Okay, so the first thing I have to do is divide the top and the bottom and then find when it's equal to 0. And I think that's the part that's confusing, is why do I have to find when it's equal to 0? Well, that's just a rule of that operation. Whenever you're dividing those two equations together, you have to find when the bottom is equal to 0. So let's say that fx is equal to, I'll go back to my original one, x squared. And let's say that gx is equal to x minus 4, okay? So that's where I start. Fx is equal to x squared, gx is equal to x minus 4. So now let's say I'm told that I want to solve for when the function of f is divided by the function of x. Okay, so whenever I'm solving for when the function of f is divided by the function of x, what I need to do is follow what the operation tells me to do. So the first thing I'm going to do is substitute or create an equation where the f equation's on the top and the g equation's on the bottom. So when the f equation is on the top and my g equation is on the bottom. Perfect. Done there. But the function or the operation also tells me that I need to find when g of x is equal to 0. That's just a rule that I have to do according to the function. So I want to find when g of x is equal to 0. Well, in order to find when g of x is equal to 0, I need to look at my g of x equation, this equation right here, and find out when it's equal to 0. Well, in this instance, the only time in when g of x is going to be equal to 0 is when I substitute 4 into x, right? Because 4 minus 4 is equal to 0. So that's my instance when g of x is equal to 0. So basically, what I just have to do is instead of it being 0 here, I'm going to plug in 4 because that's the instance in which that denominator is equal to 0. So whenever I'm answering this question, whenever I conclude, this would be my answer. So I have to include all of that in my answer. And so that's why we're looking for when the denominator is equal to 0, because I have to include, according to my operation rule, when g of x is equal to 0. And so that in this instance would be 4. Does that make more sense? Why I'm even looking for why g of x is equal to 0?
Yes.
Yes. And then we'll go over some practice problems like we normally do for this one on Tuesday. And so you'll be able to see when to actually apply these and what those type of problems would look like. Okay. And I'll even do some practice problems and post them today in case you're a little bit more confused. Okay. And so basically, what's the point of what we're learning today? Well, the point of what we're learning today is that there's certain operation rules that apply whenever we're told to add f of x and g of x together, whenever we're told to multiply f of x and g of x together, subtract f of x and g of x together, and divide f of x and g of x together. And so those rules basically tell us how to go about doing that. And so whenever we get something that looks like this, and say instead it was substituted, it looked like this. Say it had a substituted value of that. Well, according to these operation rules, what I would have to do first is find what my equation is as a result of this, adding f of x and g of x together, and then I would plug one in. I can't just go about plugging one in automatically. So basically, that's how these operation rules come apart or come to be. Because eventually, we're going to have to substitute values into those operation rules, and you can't substitute those values and find the correct answer without first figuring out what the equation would be when we do f of x plus g of x, or finding out what the equation would be when we do f of x minus g of x. So you would first have to find the equation, and then once you find the equation, then you can go about actually plugging in or substituting in that value that we're looking for. Does that make sense to anybody?
Yes.
Yes, okay. And so I'll go ahead and post some more example problems today. I'll look for some example problems and post them today so you can kind of see an example of when we're actually going to use these operation rules, because in your head you're probably just thinking, okay, these operation rules exist, but why would we even use them, or where would we even use them? And so I'll introduce some problems like that, and then like always we'll go over some example problems on Tuesday. Okay? Any questions?
No, ma'am.
Okay. If there's no other questions, you guys may log off, and I'll see you guys on Monday.
Bye, Miss. Have a good day.
Bye. Oh, no. Bye, guys. Bye, William.
Bye, Miss.
Bye.